All right, let's take a look at the Module 5 coding challenge. So what we want to do here is use an external API. What that means is that we're going to have access to someone else's data. Now, that someone else in this case is the St. Louis Federal Reserve, who, as you might remember from your various other econ classes, have a ton of useful data. And the way we're going to access that is using an external library, the FredR package, which is going to make it easier for us to use this API. So behind the scenes, what we're going to be doing, I'll get to my code in just a second. Actually, let's get to my code right now. So what is fundamentally happening behind the scenes is when I load in this library, it's going to have some code that makes it easier for me to get and use the data. But behind the scenes, I'm sending them some information that lets them know it's me. That's the API key. We'll walk through that in just a sec. I set that API key, and then whenever this library calls to their server to get data, it says, hey, this is Rick looking for data, gives them details about the data that I want, and then it sends it back. Behind the scenes, it's doing a whole bunch of HTTP requests, server stuff, right? Computer stuff that is fiddly and kind of a pain for you and I to deal with. But with the FredR library, a lot of that is just simplified into the background, right? So we don't have to manually write out an HTML request to some server with a whole bunch of specific details. We just say, hey, I want the data with this name, CSUSHPINSA, and that's going to give me something back. So when I run that, it dumps back a bunch of data. Nice and easy. So let me start by explaining the API key. So the API key is going to be a necessary component to get this to work, and I believe I've got details on that over here. So over on the Fred St. Louis page, oops, where am I going? Over here on this page, you can log in. Let me get out of the way. So I've got my account. Let's go ahead and open this up in a private tab, just so I'm not logged in. So you go here, it'll say log in or set up an account. So create a new account. Might as well use your Farmingdale email address. Blah, blah, blah. You can subscribe to newsletters. You can say that I am a student. Go through that process. And then once you've got through there, you'll be logged in and you'll be able to get an API key. So under my account, we've got API keys. Now I have this key that I created 3.5 years ago. This key, which I am now exposing onto the open internet, allows me to interact with someone's computer, someone who is implicitly trusting me. Now I'm going to have to delete this key now that I'm putting this video on the internet. So if you try and use this key, it's not going to work. If you accidentally share your key, now you and I were not high profile people, but like if Beyonce is learning R and she accidentally shares her API key on Instagram, suddenly people are going to grab that key and they're going to abuse it, right? They're going to make a bajillion requests to the Fred St. Louis webpage, to their server, and it's going to be a real pain, and they're going to shut down your account once they realize there's a spike in activity and someone's messing with them, right? So this is a secret that you want to keep to yourself. This secret I'm going to have to remove and create a new one. But with this one I've got, I'm doing the not super secure, kind of lazy way to do this. I'm just in my script setting, here's my API key, and then I'm loading that API key. Now, in practice, what you really want to do is you want to keep this key in a separate file that you're not going to share, right? So you definitely don't want it getting synchronized with your GitHub. So in practice, we use something like an environmental variable, which basically just means there's a hidden file in your directory that isn't getting sent to GitHub, but you can read that file, get the API key, and then on this line of code say, whatever we got from that file, that's our API key. That's what's necessary to get the rest of it working. All right, So we've got an API key. What we do now, probably the simplest thing is just go to, so I've got the link to FredR, and then further below under usage, it says get started. So the first thing to do is obviously install FredR, which is just this line of code here. Oops, that's not what I want. You can install that, although actually that link is helpful. So this is obviously assuming that you're working on your own computer where you've already got R installed, and ideally RStudio also, or VS Code, or whatever other IDE you want to use. If you're having problems with that, a really fantastic website is rdrr.io. And RDRR is an old school Simpsons reference, so extra little bonus there. But RDRR will let you, let's see if this close works. Oh, never want to press any of the buttons on a pop-up like that. But once you're here, you should be able to do library FredR. Let's go ahead and just grab all this and see if it works. It's waiting because we're using someone else's server. It's going slow because we're not paying them a lot of money for this. Just that one ad that I didn't even click through. And we run into some problems. Couldn't resolve. All right, that might just be an issue of their server said, hey, why is this request coming from a different IP address than what you just sent out 5 minutes ago from some other IP address? Don't worry about that. Long story short, RDRR should work for you if absolutely necessary. But assuming you don't have to do that, you install FredR on your local computer. You use library FredR to get access to the code, to be able to use it. Right? So in my script, I'm calling library FredR. I commented out this install line because I don't need to use it anymore. Right? And I'm going to delete these. I don't need these in my code anymore. So I load in these libraries. I set my API key in a very insecure way. And then I load in that API key. For our purposes, it's going to be fine. What you can do is when you're submitting your work, or if you're putting this up onto GitHub, just don't include that line, right? Or replace it. So I just put something in there to hold that place. You don't want to be putting your API key out and then deleting it all the time. But whatever, right? So you've got some API key. Obviously, you want to make sure it's going to work. So you'll have it like this while you're doing your work, and then when you submit it, you'll get rid of it. So at this point, we should be able to pull down some data. So here's an example bit of code that the FredR documentation gave us, and we can see that it is pulling down some unemployment rate data for a whole bunch of different months. Great. So this is the power of APIs, is we can pull lots and lots of different data from them. And even better, once you set this up, so let's say you're interested in the unemployment rate and sales of consumer goods. Right? You can make some sort of a dashboard that's going to give you some indication of should you be worrying about your plans for the next quarter for your business. With the API, because it's pulling data from someone else's server, we can just rerun this in 6 months and pull in the last 6 months of updated data. Right? We don't have to download a new file, clean that file, and rerun stuff. The API is going to make it work faster for us. Behind the scenes, again, FredR is doing a lot of heavy lifting for us. And maybe we want to change the format a little bit, and so maybe we have a little bit of code after we download it, right? So we say here is our data frame is going to be the results of this, and then maybe we do some sort of a mutation, right? Whatever that may be. All right, so that's the gist of using this API. Now, what is our assignment? Our assignment, where did I go? Is to recreate is to get the data so that we could recreate this graph. I've got a bunch of open tabs. I'll just open this here. So the graph we're trying to recreate is from the Fred blog, looking at the question, are home prices decreasing? And they've got 3 different series that they're using. So you can click into those series to get some details to use this stuff, or you can go to the graph that they link to on that page, and this will give you some of those details. All right, so we got the Zillow, and notice here in parentheses, this long code, this is the series ID we're going to drop into here. So we're going to get those 3 series, the Zillow Home Value Index, the S&P CoreLogic Case-Shiller U.S. National Home Price Index, and All Transactions House Price Index for the United States. And so we're just downloading that data, combine it into a data frame, and that is the bare bones aspect of this assignment. All right, so pull that, get that data, roll it all together. Now, if you want to go above and beyond, get some more practice, 2 big things. One is actually recreate the graph, right? So learn a little bit of ggplot2, do a geom_line to pull this stuff together and get something that looks like this. And then the other thing is to get some other data and get a comparison, right? So this national level data, this is kind of cool. We can see how these different data series reflect things, the little variations. Obviously, they're going roughly in line with one another, but there's some little variations. What I want to see is something more specific than national, right? So if you've got this national data, how does that compare to, say, Suffolk County? So you can go in here. Let's say we go to housing. We can look at geography types. So maybe you look at the New York metropolitan statistical area. Geographies, we go New York, right? You can sift through this, find some data. Maybe we want to do this one, right? Literally just the first one that came up in this search. So again, you grab this series ID and then make a comparison, right? Is the change in housing prices that we see locally in the New York City MSA, how does that compare to the national average? Another one, right, Suffolk County. So if you search for Suffolk County under housing, you might find some stuff. You could go in a different direction also, right? It doesn't have to necessarily be comparing a specific area, although that's something I think is interesting. Is Suffolk County seeing different forces than the national average? You could do something like compare the unemployment rate over time and see if we see a relationship, say, between changes in the unemployment rate with changes in these housing price indices. Basically, just bring in some other data and get a little bit more context than just the national averages. So in the assignment, I say, make a comparison to some specific area like New York City or Suffolk County or, wherever, right? You got a friend in Denver, compare Denver. But it's open-ended. You can do something, something else, right? Pull in some other data and make a comparison. So that is this coding challenge. Relatively straightforward once you get stuff set up. All right. If you've got other questions about that, let me know. Otherwise, I will see you in the future.